Hello everyone, myself Mrs. Rama Ranjankar, lecturer in Electronics and Telecommunication Department from Praveen Patel College of Diploma Engineering and Technology, Bhindar. Now I am going to explain chapter number 3, Television Fundamentals and TV Transmitter Part 2. So learning outcomes of this topic are composite video signal and horizontal and vertical signal. Composite video signal consists of a camera signal corresponding to the desired picture information, blanking pulses to make the retras invisible, and synchronizing pulses to synchronize the transmitter and receiver scanning. A horizontal synchronizing pulse is needed at the end of each line period, whereas a vertical sync pulse is required after each field is scanned. The amplitude of both horizontal and vertical sync pulses is kept the same to obtain the higher frequency of picture signal transmission, but their duration is chosen to be different for separating them at the receiver, since the sync pulses are needed consecutively and not simultaneously with the picture signal. So these are sent on a time division basis and thus form a part of composite video signal. Camera signal which corresponds to a light variation in this signal. So it defines light intensity, blanking pulse. Blanking pulse makes the retras invisible. Sync pulses is to keep the scanning. Chroma and color burst are added in composite video signals. So horizontal sync pulse are also added at the end of each active line period. Vertical sync pulse is required after each field. The amplitude of both the horizontal sync and vertical sync pulse is kept the same to obtain the higher efficiency of the picture signal transmission, but their duration is different. Sync pulses are needed consecutively, not simultaneously, so they are sync on a time division basis and thus form a part of composite video signal. Peak white level is also present, so it is at 10 to 12.5%. Black level is there, approximately present at the 72%. The sync pulses are added at 75% of level, called as blanking level. Difference between the black and white the black level and the blanking level is known as pedestal. Difference between the black and white, that is 75 to 70%, is also called as a pedestal. So pedestal height is the distance between the pedestal level and the average DC level. In DC level, this indicates the average brightness since it measures how much it differs from the black level. So brightness is constant in frame, but it changes from frame to frame, not line to line. Sync pulses are used to trigger the sweep oscillation and are placed in the upper 25% of the video signal, that is from 75% to 100%. Horizontal sync pulse. Horizontal sync pulse is synchronized to horizontal scanning oscillator. So front pulse is approximately 1.5 microsecond inserted between the end of picture information for that time and leading edge of line sync pulse. Front interval allows the receiver video circuit to settle down from whatever the picture voltage level of previous line or at the end of picture line to the blanking level before the sync pulse starts. So horizontal retras is introduced at the sync pulse starts. Flyback is definitely blank out because the sync level is blacker than black. 4.7 microsecond is the duration in which the beam on the raster almost completes its backpose and comes out to the extreme left end of raster. Backpose allows the line flyback to be completed, and it allows the horizontal time-based circuit to reverse the direction of current for next scanning line. So this is a diagram for horizontal sync pulse and vertical sync pulse. Vertical blanking pulse and sync pulse. Vertical sync pulse is added at the end of both even and odd field. Its width has to kept much larger to drive suitable field sync pulse at the receiver to trigger the field sweep oscillator. So vertical sync period should be 2.5 to 3 times horizontal time period. And the horizontal line period is 64 microsecond. Vertical line period is 160 microsecond. 160 microsecond is allotted for the vertical sync pulse, and vertical sync pulse start at the end of first half of 313 line. So this is a figure for vertical sync pulse. Concept of equalizing pulses to take care of drawback which occurs on account of half line discrepancy. 5 narrow pulses are added on the either side of vertical sync pulses. So these are known as pre-equalizing and post-equalizing pulses. Each set consists of 5 narrow pulses occupying 2.5 lines period on the either side of the vertical sync pulses. So pre-equalizing pulses duration is of 2.3 microsecond and result in the discharge of the capacitor to zero voltage in both the post-equalizing pulses necessary for a fast discharge of capacitor to ensure triggering of the vertical oscillator at the proper time, and with the insertion of equalizing pulses the voltage rise and fall profile is the same for both the field sequences. The vertical oscillator is triggered at the proper instant, that is exactly at an interval of 1/15 of. This is a diagram for pre and post equalizing pulses. Also pre and post equalizing pulses, these shortcoming and its solution. Equalizing pulses are unrelated to the process of equalization that is used to compensate the poor frequency response of coaxial cable. So analog synchronous shown in diagram illustrate the development of combined synchronous waveform. So every line outside the vertical interval starts with a normal sync pulse having a duration of 4.7 microseconds. Vertical sync is identified by a sequence of broad pulses, each having a duration of half the line time less a full synchronous width. The broad pulses are serrated so that a receiver can maintain the horizontal sync during the vertical interval. So when the analog sync separators comprised just a few resistors and capacitor, imperfect vertical sync separation was prone to exhibit line pairing, where the scan lines from the second field were not laid exactly halfway between the lines of the first. So the line pairs were prone to visible. Achieving good interlace required interposing narrow equalization pulses, so each having half the duration of normal sync between the line sinks. So there are 3 lines of pre-equalizing pulses, 3 lines of broad pulses, 3 lines of post-equalizing pulses. Thank you.